Alright, now that we have established our run for our part, we want to go ahead and put on a dog to drive this. We'll slip the centers on. We'd have the lube on there. We want to confirm that we are going to be able to use this because we have lengthened this out here, and we want to make sure that when this is locked on here, do we have a jaw engagement here. Alright, and I believe originally I welded this little tube on here probably 20 years ago, so that, well, maybe 17 years ago, so that I could make contact with this jaw when I first made that first center attachment for this lathe. And I kind of favored this center. I have another center that's just like this, same comparable size, with a short dog. So if I was in a situation where I needed to use that, I would put this one on here or this one here. Try to keep multiple choices. You'll see a lot of different machine shops and you'll see a lot of different dog combinations, and that's because you need to have a variety in this as well. Diameter and offset to hold it. Here's another kind, and this is a homemade dog as well, and somebody used some nice square head bolts here, which is really cool, and probably heated this up and had this round diameter tagged off of it. They actually put a couple V's in here so that this would expand on several different diameters. And I've seen a couple of these sometimes with the V slots, a couple of them going up and down this way here so that it could go this way to engage the difference between in and out on the finger itself from that diameter. We're going to be happy with that. We're going to use this dog, and we're going to go ahead and lock this thing on. And because we're going to be turning on this diameter here too, probably, we're not going to bother putting anything in here. But later on, if I chuck on or put my dog on an area I don't want to mar, I'll show you that I actually put a little piece of aluminum underneath here. And if I forget about it and you see it, you'll know why that piece of aluminum is underneath the bolt head here, so that it doesn't put a mark on it. This V shape to the dog, just like this V shape to this dog, is like a V block, and that holds it steady side to side, and really when it draws down on there, it locks it in solid, so it becomes part of this rod. Alright, now we're going to go ahead and pull this out of here, and we're going to apply pressure lube here, and we just give a little dab. I put it in both, even though we're using a live center on here, because I know I'm going to be endoing this thing probably also, and it doesn't hurt. Now, how much pressure you put on there, you want to make sure that it's not going to come off of that dog when you let off on your RPMs. You want enough pressure in here so that the harmonics is not transferring because you are holding it too loose. There are a couple of variables. You will find out, and you'll discover those as you run it. But most of the time, if you have got a slight firmness to where it'll hold against there, and when you rotate it down here, the dog does not swing down underneath. The dog would swing down underneath if you didn't have it tight enough. I'm going to back off the steady rest right now. See? Okay, so you know you can't run it like that, but you have to have a little bit of pressure there, and just enough so that it doesn't free fall on its own, and that's tight enough. All right, now we'll go ahead and rotate this. All right, we're ready to do some machining. Let's plan out kind of how we want to shape this out, and then we'll get going. All right, we just figured that we're going to want this to be riding somewhere in the center of this, so that we'll be able to chuck on this in the index head, and we'll be able to run this out and have a live center back in this area right here. And usually when you're cutting a gear, you have an area out here you come in, make your pass, rotate, index, make your pass. So we're going to go ahead and we're going to figure about there. We're going to have a flat that's going to be the bore or the snug fit where this will slide on, and we'll go ahead and we'll probably put a little woodruff key in here. And then to hold this on here, we've picked out a National Fine nut, and we'll probably thread it in this area right here, and we'll give it the V thread. After we put this together and we screw this on here, the mating face of one side of this nut has got to go against the gear itself, and I want to go ahead and make sure that that is running parallel with the thread. So we're gonna machine this whole thing. We're gonna screw this on here, and then we will be taking our indicator and we'll be double checking and making sure that we have a machined surface that goes against there, so that when we tighten it down, it does not tend to want to steer or bend the shaft, so that we want our centers on this shaft to be true in line with our bore. And sometimes when you have a threaded portion of your spindle, let's just say a pump shaft or something like that, if that face on that nut is off, and when you tighten it up, it puts a force or a bend in the shaft and makes it run out. So we want to make sure, we're going to be watching that, making sure that we have, this is short and this is stout, but still you have that chance of that actually happening. So just kind of keep it in your mind there for a project that might come down the line where it might be a spindly long shaft like a pump shaft, and you have a nut that holds the impeller on, and you have a bearing support out past that, you're going to have problems. All right, just past experience has learned me. All right, I have my DNMP here with a positive acting top side on it, and we're going to go ahead and we're going to whittle some of this off of here. We're going to get this down to 1.25 inches plus a couple thousandths. Alright, this diameter on this is 1.5 inches, give or take a couple thousandths. Need some feed in here. We're going to be using a pretty aggressive feed. About 50 thousandths on the depth here. Stock will break off pretty good and leave a pretty good finish. I brought you around to this side so that you can see the chip action coming off. Here's another cut. I just changed this insert here. Same cut of 50 thousandths per side. You can see the machine marks in this cut now, and you can see how the chip is breaking a little faster. This leading edge right here is not so rolled up. Got 1 inch to 88, and we're checking it here and there, and I'm getting exactly even both places here. I am right on the money in the middle as well. So this position, this amount of travel on my lathe right now is giving me a straight cut. We got to go down about 30,000, about 15 per side. So we're going to take a 10,000ths cut. And right there is about 169 and a half. Okay, there's 259. 259. There's 258 and a half. Finish is real good. Okay, I came down, hit that shoulder, came out, and then gave a slight plunge so that I know that I had a flat shoulder, so that the bore of the gear, or the bore of the blank, will be able to slide all the way against the face, even if there's a slight problem with the radius in the corner there. This tool bit I have has a pretty good radius on it. So by going in, I make sure that I have a flat surface 100% to be able to mate up against. Alright, let's see where we're at now. We should be able to just hand sand. We're 5 3 3/4 or almost. Okay, we're at 1 inch 254. 1 inch 254. Alright, so we're going to go ahead and we're going to mark this off now. We're going to come in, or excuse me. Alright, the thickness of this gear here, we're going to come in and bring that diameter down to 1 inch. This will be all 1 inch now down to that diameter. And then we'll worry about how much we're actually going to shorten this up so that we have a positive face against there. Alright, we got a couple over our diameter right there, which we'll polish down. Our length is just about equal with our gear and our blank, so we're going to take a little bit, we're going to make a little bit of relief there. The threads, the thread OD is right on the money. Okay, so we're going to have threads in here. We want to put a little thread relief in there, and then we want to break this corner and we want to break this. This is smaller. This nut should slide down over it and then spin on right there. So real quick, we're going to go ahead and go through the procedure of creating a clearance and everything else, and then threading that. All right, now this is a 1 inch 14, I believe, and we're going to go through and kind of show you. Now everybody wants to know how I'm able to disengage and then re-engage. There's a thread dial. Thread dial is down here. Now I'm going to just remove that right now so that you got free and clear. This is a travel dial. That's actually where I can set any longitudinal travel reference. This right here is a thread dial. When I get set up here, that'll be rolling around, and we're going to be watching that, and that's how I'm going to be able to create my engagements. All right, now here is 14, just verifying, because I don't want to get started and be cutting the wrong thread, which I have done before. So you want to make sure so when you get into like numbers and then your head gets off onto another tangent or something like that, you'll be thinking the diameter and the thread, and then you'll be off. Okay, we're going to be cutting 14 threads per inch. That's 93 thousandths double depth. So what I like doing is going ahead, setting up my dashboard gauge, which I will in a second. Right now we need to go ahead and create a relief in here and break these two angles. So that's what we're going to do first. Alright, so I get some light set up here, and I'm not really doing any more feeding, so I can take and disengage my feed. Alright, now I know that this is X amount of depth here, about 100 thousandths less than the thread. I'm going to come and kiss off the surface there. We set our travel dial here at 0. I'm just going to take an extra 50 thousandths off of this face and come on down. I touch the 1 inch, come back into our 50 thousandths. I set this dial at 0, and I need to take about 50 thousandths per side off. So they come in a little bit, there's about 30. I can start giving it a radius here. Now I'm just coming in by eyeball now. Okay, I like that. We are going to just double check that. This is 905 out here, and this is 9 or 894 there, 896. All right, we switch out. We put our other D and P in there. That breaks all of those corners there. It kind of gives a nice start or leading edge for the threading. I kind of like to do that. It's just a good habit, or a habit, not a good habit. It's a habit I'm in, okay? Let's go ahead, get set up for threading. Now we already set our compound, so we're all set and ready to go there. I like to bring this in after I know where I'm going to be here. I bring this in and find where it's going to be close. Then I want to set this dial because I want this handle to be and ready to pull out. I like my handle about right there, so that's where I'm going to set my 0 on my dial there. Okay, I pull back any of the backlash out of my carriage. I bring this in, I touch it. Okay, I'm not putting a thread there, I'm putting a thread there. Okay, thread dial's at 0. Alright, come in, touch, there's 0. Dashboard gauge. Okay, I like 0 somewhere up in here, like this. Now I've got 0, 0 here. You can set this if you want. There's 0 there. All right, let's give it some 14 threads here, and that'll be a DA on there. Alright, now as far as speed, you want to go with something that's comfortable. Now, our travel dial, or our thread dial is rotating around. Now, I usually use the numbers as my indicator. And as long as you're on an even thread, you can pick any one of the numbers. If you pick a line, then you're going to be cutting halfway in between your regular path. So either a 1, 2, 3, or 4 is the numbers I'm going to go for. Alright, I'm going to leave the number down here, and we're going to go for the 4, and I pull it up and I engage it. Now I'm coming across the thread here, and I pull out. Now I check it with my gauge. And I'm cutting exactly what my gauge is telling me to cut. Okay, so now I bring this back because I pulled out at the end. I bring this into 0. Okay, that's 0. This is still 0 here. I want to go ahead, and I know that 14 is 93, so I got about 46 and a half, 47 thousandths to actually go. So I'm just going to take 10. 10 per pass. We're waiting for the 2 to come up. There's the 2. We engage it. So this is how I'm able to go ahead and pick up the thread pass each time I disengage it and bring it back, instead of leaving it engaged and then reversing it. Okay, 0. There's the 10 we had. There's another 10. Waiting. There's the 1. There we go. Alright, with the leaded stock, I don't really have to put the cutting oil on here, so you can get a good idea what's going on. Alright, out. In. There's 0. That's your 20. Here's your 30. Number 4. Here we go. Alright, back here. Back into your 0. There's your 30. There's your 40. Okay, now we're getting close, so we're going to back it on down. We're going to take 5 and then a spring cut, and we're going to check it. There's the 2. Okay, now a spring cut. We're not going to adjust anything. We're just going to bring it back into our 0. We're not advancing anything. We're just waiting. We're going to be cutting it at the same settings we did before. There's the 1. Here we go. See, it's double cutting because I offset just slightly on my normal setting right there. All right, I like that. Okay, now we can leave everything just like we are right here. The only thing we can't do is you can't mess up with where you have the dog. If you pull this out of here and you don't remember where you have that dog at, you have 1 in 3 chances, or 2 in 3 chances of screwing up. Okay, see this white dot right here on my chuck here, or my face here? You know, I can choose to use that, but I choose to also put a mark on there, okay, or you know that's your chuck point, and right there is the jaw that it's leaning against, okay? So you want to make sure that you mark that, okay, because I am going to go ahead and I'm going to loosen this, and I'm going to take this on out. Now we're going to go ahead and slide this down here, and we're going to check the thread fit. And I happen to like my thread fit. I like that. Okay, well, let's just say that it didn't fit on there tight. We're going to put this back in there. I'm looking at matching up that. I'm bringing this in here, holding that against there, relocking my tail, bringing this back in here, boom, boom, we're bringing it back in. Here's the 4, okay? You can see that you're lining up perfect. Okay? Alright, now that we got that, we're going to go ahead and polish. We're going to double check this fit, and we're going to make sure that our hub fits on there. But we need to go ahead and mount this nut and see if this face runs out, or if it runs true with the axis of the threads. Alright, we check this fit here, right to the shoulder, nice and snug. I like that. The new one, The new one might have a little burr on the keyway or a little tight, and I don't mind it being like that either, but I will go ahead and make sure that it has nothing that is going to be causing a galling or anything else on there, and I'm pretty sure that it's pretty much the same either way. Nice tight fit still, so and I'd rather have a little tighter fit on the newer gear. Alright, so what we want to do is we want to go ahead and get this on here, because our next attention is this nut before we can go put this in the mill. And we're going to turn it around. We're going to put the dog on this end here, and we're going to take a light skim and establish a perfect running true surface with the axis there. And we also have to put in the gear and give it a true cut on the outside. Alright, now this is what really gets me here, is how nuts and threads are made. I personally don't know how somebody consciously could have a mating surface or the contact washer surface of a nut run out like that, unless they're considering that to be a lock nut, so when it hits the surface it locks sideways and tightens up because of a bind. Okay, I'm gonna check a couple other of my nuts, and I have about 6 of them, and I want to make sure that I might accidentally have one that was done right. Okay, this is from McMaster Carr, and this is grade 5 zinc nuts. Okay, country of origin Taiwan. Okay, and I've had some pretty good Taiwan stuff. Okay, but right now we're concerned about how well they can make nuts. Alright, so here's my second one here. I have, I don't know, 2, 4, 6, we had 8 to test out on here. Okay, and all I need is one, guys, so I'm just asking, please, 1 out of 8. That one looks pretty true. That is almost perfectly true on that one side there, and if I lock that slightly up there, I could come in here and I could kiss that surface right there. And I think I would be pretty happy with that right there. Alright, so I'm going to take it that it was just one that got by, and let's just for kicks, let's see if we can get one a little closer. That's pretty damn good. I might not even have to do anything if I use this surface right here, this side here. Okay, I like that, and I'm looking at this, and I'm gonna use this side. I'm not gonna bother machining that nut right there, because I know I have a little bit of play, but I don't think we're not gonna be distorting the run that much. Okay, so we can run that on there that way. Okay, before I want to turn a 2-inch shoulder on this side here, so I know that this diameter is true, but I also want to create a little shoulder here so that when I put this on the index head and I'm pushing the cutter against the gear, even though we're not going to be, come on, we're not really going to be putting that much push, but still, you do not want anything moving around, so we want that to go in there solid, okay? And that'll keep the location and everything in proportion to our setup, and keeping uniformity all the way around the part is the whole key to cutting gears. We want the gear teeth to be the same depth here as over here. We want them to run true with the bore and the whole bit. So that's kind of what we're working on. Now, before I do this turning over here, because it is nice and uniform, and I can set this up right now real quick, and I can mill a key in here, or I can mill a woodruff key in on the side. I happen to have a box, and this is an old-timer box because they recycled everything that, you know, this was sucrets, okay? But there's the treasure in there, okay? It's not old, dried up, moldy sucrets. It's a good bunch or collection of woodruff keys in there. And I think that one is going to be the one I want. And I want an 1/8 of an inch wide, and I want one that's going to fit pretty much the landing, so the length of that is pretty good. I just happen to have a cutter that is pretty close to that diameter right there, that sweeping diameter right there. Alright, so I think that's what I'm going to do. I'm going to throw a woodruff key in here real quick, and then I'll be able to slide the gears over the shaft, and then the gear, or the keyway, the woodruff key, will keep it from rotating. And what I did is I made sure that we had the better fit on our new gear here. So let's regroup. Let's pull out our drill chuck and get our cutter ready to go, and I'm going to show you quickly how I put in a woodruff key. Okay, I've got the woodruff key cutter in here tight, and what I do first is I come down and I kind of put it over the top of my part here, and I'll roll it around. Let's see, let's go the other way there. Okay, so I have a tooth straight across from each other, and I can look and eyeball my woodruff key between this shoulder and the back shoulder. Now it looks like I'm centered. Okay, now I go ahead and I touch the woodruff key to the top of my part, and I set my travel dial or my spot or stop it on the quill, and get that set for a 0. Alright, then I come back out of the way here, and I take this diameter here, and that's 1 1/4, basically 1/250. It's actually 1/252. So that's half of that is 5/8 of an inch, or 5/8 plus 1/8 of an inch. So we crank in 625, 626, somewhere around in there. All right. Half of the width of the key, we need to make up the difference of that, because we're offset by half of this now. We've got this divided in half, but we need to divide the cutter in half. So I take another 62.5 thousandths for that, which makes 13/16, or 11/16, which is 6.875. Went a little past it there, 6.875, somewhere around in there, plus a thou or two, just because we know that we're fat right here. All right, now I looked at my key, and this, not every key is the same, but this cutter and this key are pretty close to the same radius around the bottom. I want to have at least 100 thousandths sticking up, because I know my keyway is or not 100 thousandths. I want at least 50 or 60 thousandths sticking up on my key, because I know I have it a little bit more than that. So this is 200 thousandths, so I need to go in at least 150 from the touch off. So I go in and I engage this, and I'm going to come in and just touch right there, and I go ahead and set my readout or set my dial, either one. Actually, I can set my dial, just because you need to dial, practice your dials every once in a while, I guess you could say. You go, nah, but it doesn't really matter. This This is really not critical as far as the depth. You can go plus or minus a little bit there. So I needed to go in about 150, 140, 150 will be the depth. Alright, there's 140, 145. Let's go ahead and we'll check it right there. I'll go ahead and get some air here. Alright, let's see if the key slips in here. Or if it's going to be a tap fit, we may have to do something else. But she's a little snug in there. Let's go ahead and I'm going to go sand it a little bit on each side here. Alright, I just rolled it on some paper here. And I got it to pop in there. Not that I'm really forcing this in here, I'm just getting a better situation here. There we go. Alright, and I can take the scale, and I am around 50 thousandths right there. So I think that's good. I'm going to go ahead and move my setup here and do a fit up on my slug here. I don't know if this will slide. Oh yeah, we'll slide in. Okay, let's check this out. That's kind of handy. Yep, she's gonna go. She's on about a 1/4 inch right now. I gotta love that. Right to the shoulder. Alright, let's spin a nut on there. Tighten it up. And we got to turn this yet. We can still turn that while it's in the lathe between centers, and then we can into it, or we can cut it. We can hold it right here, and we can turn that and turn this at the same time. All right, I'm gonna put this in a vise here, and we're just gonna snug that up just a little bit. Let's go over to the lathe. We're going to go ahead and put the dog on this other side here, and we want to go ahead, we're just going to look in here. Let's go ahead and add another dab of high pressure lube into our centers here. Alright, now just so we don't have this digging in here to the material, go ahead and we get aluminum shim here. Get that in there like that. And now when we tighten it up, the pressure's against there, and it's not digging into the shaft, and the V-block is fine. The V-block surface on that side is fine. A slight bit of pressure. Now we go ahead and turn it on. Now this is running true. We can see just a little bit. It's running true here, but we see a little bit of running out here. But we're going to skim this right here, 2 inches long with a little shoulder, and then we're going to skim this gear to the right diameter, or finished diameter. Alright, we'll go ahead and put a cut indicator on these surfaces here, here, and here, just to compare them. Alright, try that again. Let's back this up a little bit here. Okay, that works a little better. Okay, about a half a thousand's right there. About 3,000's right there. It looked a little closer right in here. And that's about a thou and a half. And this is running about 5 thousandths. And we have about, I don't know, I think what we say 30, 25 or 50 thousandths we got to take off of it. Oh, one other spot. And basically we wanted to see how true this was, because this and the bore I was considering to be the most important. And that is running less than 2/10 or so, barely flickering right there. Alright, so turning between centers and creating our shoulder to run this gear in the setup on a mill is going to be really close. So the gear and the bore are going to be running tits, and we'll just have to skim this right here and skim that right there, and we're ready to go into the mill, I guess, and start setting up our gear cutter and our index head. Okay, we're coming out here and we're going to check our tension there a little bit. We're going to add just a little bit more. There we go, it's firm. This has been sitting for a day or so. We've been on other projects here, and I just happen to have another armature that I got to get in here and skim a bearing diameter that I've had a guy come in, and he's got it mushroomed on the end. He's tried to tap a bearing on, and so I gotta massage that a little bit for him. So I thought I'd get back to this real quick so I can get this on over to the next setup, and we can move on with our gear project. But I also free up the machine here, and I have the exact setup that I need to dress up his project as well. Alright, now basically what we're going to do is we're just going to skim 2-inch length right here down a couple hundred thousandths, so we have a nice shoulder here to push against the chuck jaw there. And we're going to take and skim this to the right OD. I'm going ahead and put my high-speed steel in here because I want the positive action on here, and this is just cast material, and I'm going to go ahead. We're only taking a little bit off of here, so I'm just going to put a catcher in here, and I'm going to slow her down a little bit. Take a cut here just to establish a round diameter on here, like 15 thousandths. There we go. I'm not going to use any oil on the cast iron here. Sometimes putting a brush over your work like this will let the chips fall directly down here instead of spreading out across the ways and other areas. Okay, I'm going to get the micrometers and we'll check the diameter there. Okay, we compare the two gears that we have for samples are 5" exactly on the outside, give or take 1/1000. And we're still over 5 inches by 82 thousandths. So we got about 40 to take off of each side here. Now that last cut I did was kind of coarse, and I'm going to go ahead and break that down a little bit. And then we're going to give it 25 thousandths. That'll take 50 off of there. That'll leave us about 15 aside. Okay, we're about 39, so it's almost 40. But this is a little bit fuzzy here. I know that it'll break down with some emery paper, so I'm still gonna judge this for like about a 35 or so. All right, let's take 15. Okay, we're reading about 4 over, but we're going to polish that with some emery there, get it down. Right now I'm going to go ahead and I'm going to break both of those corners because I like to have just a little tiny flat on each side, or you know, the gear not so sharp on the outside edges. Like a strobe light with the light on that hex there. Okay, that's about as wide as the sample. That's about equal. Okay, we're about 5 inches 2, 5 inches 2 1/2. I'm getting about 1.5 to 2. I'm gonna leave it right there. Alright, we're going to go ahead and pull this out so we can get working on the other projects, and we'll be following up, starting to get this set up in the index head over on the K&T.